Welcome back. It's Rob again. We're going to have a look at some more compound interest now. We're going to look at going the other direction in time. Now that you've learned how to calculate future value or maturity value, we're going to look at doing present value. Just to remind you about the notation we picked up last time, PV is the present value or principal. That's what we're going to try to calculate today. FV is the future value or maturity value. N is the number of interest periods. Remember, this tends to work in whatever units the interest rate compounds at. So it could be months, it could be years, it could be semi-annual periods. It depends on the interest rate that we're given. M is the number of interest periods per 1 year. So it's similar to N, but it's just for 1 year, whereas N is for the whole problem. If the problem lasted for 3 years, of course there'd be 3 times as many. N would be 3 times bigger than M. J is our nominal rate, our annual rate that gets compounded M times per year. Little I is the interest rate per period. That's a pretty important one for us too. That's how much interest will work out before we do the next compounding. With M, you'll see that there's really a small number of them. You're going to get annual, semi-annual, that'd be a J2, or M would be 2. Quarterly, 4 times a year. Monthly would be the next most common one. And then daily, and then sometimes you see weekly or bi-weekly, but that's about it. We never see something where an interest rate compounds every 7 months, for example. It's just not very likely. So the choices for M are kind of limited typically, which makes it easier to learn and work with. But if you're still not very comfortable working with these, figuring out M and I and N and all those things, I would take a little bit of time to go back to the very beginning of our chapter and work through some of those questions in the textbook just to make sure this is really just natural and easy for you. It'll make it a lot easier going forward. Let's see if we can come up with a formula now. And just like we did with simple interest, we often think, well, I know how much money I want to end up with. What should I start with to get there? So I want to kind of work backwards in time, essentially. I'm going to rewrite the basic future value or maturity value formula to find the present value, or PV, same type of process we used back with simple interest. And here's what we get. The future value was present value times 1 plus I to the n. If I take both sides and divide by this 1 plus I to the n, I end up with this thing right here. Present value is future value over 1 plus I to the n. I flipped it around left to right to get the present value on the left. But I end up with that formula. I'm going to take it a step further now. I want it all to be on one line. So if you remember, we talked about this earlier, or you might remember this from high school. If you have something down here in the denominator and you want to bring it to the top, you can make the exponent negative. So we end up with this version here. That's the version I want to use as we go forward with our work today. So future value times 1 plus I to the power of negative n is going to give you the present value. Just like before, we have different terms for it. Discounted value, present value, price, original amount, investment, things like that. Those are the terms you look for when you're reading a word problem that may give you a clue that it's this type of question. Let's have a look at an example. How much money would you need to deposit today if you wanted to have $100,000 waiting for you 20 years from now? And let's assume that we can get 6% on average compounded monthly during that time. All right, so I'm going to start, like always, by writing down the things that I know, as well as the thing that I'm trying to get, just to clarify my thoughts and really get rid of the word part of the problem if I can, make my life a little bit easier. So I got the 100,000. The next thing along here says 20 years. So n is going to be 20 years times however many times I compound per year. In this case, it's 12. So that'll be 240 periods, 240 months. And then the last thing it tells me is we get 6% per year. So I is going to be that 6% divided by 12. And that will tell me how much interest I get per compounding period, or per month in this case, 0.5%, 0.005. And what is it we're trying to find? we want to find what we have to deposit at the beginning today in order to make all this work. So let's take our formula for PV, future value times 1 plus I to the power of negative n, 100,000 times 1.005 to the power of negative 240. And on our calculator, you can still use that y to the x button to enter your exponent. What you're going to do is press y to the x, type in 240, and then press the plus minus button. Right? The plus minus button located sort of down lower on your calculator there in the lower right area. That's going to flip the sign to negative for your exponent. So you actually press it after the 240 on our calculator. All right. If we enter all that in there correctly, you should come up with $30,209.61. That's how much money we put aside today. The money will sit and grow, and then at the end of our time period, we're going to have $100,000 waiting for us. And that's it. That's how we get present value, and that's an excellent thing to be able to do. Let me give you one to try out to make sure you can do it as well. How much money would you pay today for an investment that promised to pay you $5,000 3 years from now if you wanted to earn 8% compounded quarterly on your investment? All right, so you get to determine the price, but you want to pick a price that'll end up being an 8% return for you overall on average compounded quarterly. So why don't you hit pause right now, try and work your way through it, see if you can come up with the answer, and I'll come back in just a minute when you're ready. Press play and I'll go through it with you. All right, let's have a look here. In this case, we want to end up with $5,000, or that's what we're going to get. And so we want to, that's our future value. We're going to figure out what we should put aside today to get there. We've got 3 years. So n is 3 years, and we're compounding quarterly. So that means I'm going to have 12 compounding periods over those 3 years to let my money grow. The interest rate per period, well, it was 8% compounded 4 times a year. So that gives me 2% or 0.02 per period. And we want to find the present value. I'm hoping you took the time to write things down because it's a great habit to get into. And it really will pay off as we get into the more complicated questions coming up as we work through the material. So there's the starting values. Let's pull out the formula for present value. Future value times 1 plus I to the negative n. Let's put in our 5,000. 1.02 to the power of negative 12. As we work through that, $3,942.47. That's how much money you'd have to put in today, or that you'd be willing to pay today for that investment. It'll pay you $5,000 in 3 years. That gain of a little over $1,000 you're going to make will represent an annualized return of 8%. All right. If you want, it doesn't hurt to think about a timeline for some of these. What we've done here is that how much would we pay today for something that will give us $5,000 in 3 years? All we did was take that $5,000 back at our rate for our number of periods, and everything's working in quarters for this question. And that's simply it. So we just kind of gone back in time to work this one out. That's a great thing to be able to do just for simple questions like this, but it's also going to play a role in the bigger questions as we go forward, where it'll be one piece of what we need to be able to do. So this is a great point to stop, return to your textbook, practice a whole bunch of these. Again, as you're going through these, take your time, read the question, write everything down, get organized, right? That's the key to success with this kind of question. Make sure you're working in consistent units. So if the rate's compounded monthly, make sure n represents months. If the rate's compounded annually, make sure n represents years. That sort of thing. Use all your decimals during calculations. You're going to see when you work out the bracket part of the equation, you may end up with a lot of decimals. You want to keep them all. You don't want to do any rounding because that's going to really throw you out with your final answer, because any rounding error gets compounded over and over again, and we don't want that. So that's it for now. Go back to the book, practice a bunch of these, and when you're ready, we'll work on our next piece.